All right, welcome back. So we are looking through homework 7 right now, and I just finished up the video for number 2, and let's begin number 3. So for this, we are asked to create a 3 by 5 matrix of random integers, each in the range of -20 to +20, assign them to a variable A matrix, or A mat, and then we are going to do a couple of different things. The first time we're going to write a single nested for loop that uses if and array indexing to accomplish the following objectives. Don't use any built-in max functions. So we want to look for the max value of each column, store it in a vector variable call max, find the max value in each row, store it in a vector variable row max, find the max value in the matrix, and store in a scalar variable mat max. Hint, before the loop, initialize call max to the first row max to the first call, and mat max to the first element. So I think this would help us to it might help us to do a little bit of like what ifing on this. So I'm going to make, what is this, a 3 by 5, 3 rows, 5 columns. I'm going to pretend that I've got a, building that matrix here. So 1, 5, 6, 8, 9, -5, 12, 11. I'm going to try and line these up a bit just so we can. 2, 3, and then maybe just 1, 2, 3, 4, 5. Okay, so maybe this is the results of our random matrix creation, right? So the first thing we're supposed to do is find the column maxes, right? So as I look down the columns, the max of each column, right? So this is going to be a 1 by 5 because there's one max in all 5 columns, right? So from the first column, the maximum is 1. From the next column, the maximum is 12, 11, 8, 9. Okay, so that's the idea. Same thing for row max, and this time there's one maximum from the first row, so this should be a 3 row by 1 column. Right, so in the first row, what do we have? A 9. And then next row down, which I'm just going to do with the semicolon, but the next row down, we've got a 12 as the max. And the next row down, we've got a 5. Right. And then, of course, the last one is mat max. This is just a scalar. It's a single number, the largest of all of them. And I think we could just look at either the row or the column matrix right now to think about it. These are all the largest values from each column. So 12 is the largest of the largests. So 12 has to be the matrix max. And the same logic works with the rows. These are the maxes of each row. 12 is the max of the maxes. So the max for the entire matrix must be 12. Okay, so that's our idea. Now we're asked to attack this using a nested for loop. So we're going to be going for, we're going to run through all the columns, and then we're going to run through all the rows, and we're going to do it nested wise, so that we're just going to go look at this element, then this element, then this element, then this element, then this element, and then jump to the next row. So that's our plan of attack, is we're going to go through all of those, jump to the next row, go through all of those, jump to the next row, and go through all of those. All right, so that's just me helping myself understand the problem. Now I have an idea of the sizes of things I'm looking for. And I think we might be ready to begin. So I'm gonna put this over here. Let's start a new script. My scripts always start giant. For now, I'm just gonna, yikes. There we go. All right, so kind of some pseudocoding here. First, we're going to generate our 3 by 5 random integer matrix. Then we're going to pre-initialize our max vectors Then we're going to do a nested for loop to run through a mat, and then maybe report maxes or something. And maybe a CLC and a clear up here. So this is very generic code or pseudocode, but I think it's kind of all of the right ideas. So you could go into a little more detail probably, but this gets me going and thinking about it. All right, so a mat needs to be a random integer matrix. So I'm going to be using the rand, that makes random integers or pseudo-random integers. All right, and if we put help on it, you'll notice we could do randy I max, size 1, size 2. So we can do, we're going up to our maximum integer. But if we look in the description a little bit more, it says it goes from 1 to I max. We want ours, remember, in the words of the problem here, we want it to go from -20 to +20. All right, so if we want to, that range is 40 values. Right, so I might want to go from 1 to 41, so I have the same range. All right, so I think I'm ready to begin here. So my randy is going to be, automatically it starts at 1, but the maximum it's going to go up to is 41, so there's a range of 40, and it's a 3 by 5. And then instead of going from 1 to 41, I want to go from -20 to +20, so I need to subtract 21 from all of those elements. I believe that'll work, and we might as well give it a run and just kind of double check the values of our AMAT. If I tell it to run, it's going to ask me to save it. This is question 3. Homework 7, question 3. And change into that folder. Okie dokie. So does it look like it worked? Yep, here's my AMAT, and if I open it up, there we go. It is a 3 by 5 matrix. From -20, the smallest value I see is -19, up to +20, I'm seeing some 17s here. So it looks like it's working. It looks like it's doing what I wanted, and I could run it a couple more times just to be sure. Right, nothing has been over 20 or less than 21. So I think my logic, it was sound. All right, now our hint said to pre-initialize our vectors to the first row in the first column. Oh, there we go. So call max equals a max. We want the first row, but every column. Our row max, we want to be a max, but only every row, just the first column. So the first column of a max, and then mat max can just be the first element, which I think we can just call 1 or 1, 1, and we're good to go. So again, if I hit run, oh, it's a mat, not a max. It's a mistake. All right, there we go. And maybe I'll look at my workspace for this one. So here is my matrix. Call max is -3, -3, 8, 8, -15. Yep, that was the first row. Row max, -3 to 18. Yep, that's the first column. And the first element is mat max. All right, so it looks like my pre-initialization from the hints is good. And now I'm ready to run through my my element, so, or my AMAT, and look for the maximum. All right, so for row, maybe I'll just use R for row equals 1 through, you know, I was not very general up here, so maybe I'm going to generalize myself a little bit. So I can say rows equals 3, call equals 5, and then my matrix goes for row call. And then I can be, R is going to go up to row. And C is going to go up to call. And so I'm just running through from the first row to the last row, which was built using these variables up here. And then from there, I'm going to go from the first column to the last column. So that's starting to run through. And if I think about how this is working, the first time I enter my for loop, R is 1. So I'm in the first row. And then I'm going to go 1 through call. So 1, 2, 3, 4, 5 is call. So I'm going to be running through row wise. I'm going to go all the way through the first row. Once I'm done with this for loop, I've made it to the last column. It's going to come back up. R is going to become a 2. So now we're going to be on the second row, and it's going to, again, call is going to go from 1 to 5. So 1, 2, 3, 4, 5. We're going to exit that inner for loop, go to the outer for loop. R is going to be 3 this time, which is the last value. And then columns is going to go 1, 2, 3, 4, 5. So I'm running through kind of this way. And then I think we could actually get away with starting at number 2. Based on the fact that we've already assigned our values, the first row and the first column. But just to be safe, I'm going to look through my whole matrix. And we don't technically need these suppressions. This isn't a variable that's created or anything. All right, so now I need to decide whether every element I look at is bigger than the current maximum that I have stored. Remember, my current max is just the first row for the call max and the first column for the row max. So right now it's saying for my call max, this one is the maximum. It's the first one we saw. So we're probably going to want to do something like the next time we're in row 1, if this value is bigger than the current value, then we are going to save it as the new max, or save it as that new element, right? So I think that'll look something like if mat r comma c, right? So we're going to go through every combination of the row and column. So we're going to every position or every element of mat. If that is larger than call max, which really only has one row. Remember, it's just a vector, the first row. We made it the first row of AMAT, so it's only got one row. So the first row, comma, but whatever column we're on, right? So when we're looking at C, or if C is, I don't know, 2, then the second position is going to be comparing only the second positions, right? If C is 1, then we're looking at the first positions. So again, as we run through this, it's going to say is R is 1 the first time, so we'll go through the first row. If it's larger than our current maximum value, then we're going to save our into our maximums, whatever value we're at. So again, the first time we go through, let's just talk it through. The first time we go through, R is 1. So R is a 1, and then C is 1. So if this value is bigger than whatever value is in my maximum, make it the new maximum for only the first column, because remember, C is 1 here. Then when we're done with that, we're going to go to the end of this for loop and do our rows in our general matrix as well, but it'll come back up. Now column's going to switch to 2. So we're still in the first row, but now column's 2. So if the value that we're looking at here, 1, 2, is bigger than the maximum in the second column, then make our maximum that value. The third, then it's going to do all the other work, come back up. Now our column is 3. So now whatever, if this value is larger than whatever's in the third column of our max, then stores this as the new max. Which the first time through doesn't make sense because doesn't make perfect sense because they're all the same. So they're all equal because we set the first row, which is why I said we could probably start up here at 2 on each of these. But just to be certain, I want to go through the whole thing. Okay, so then once we're done with all 5 columns, we're going to now let row be 2. So we're looking at the second row, but column is back to the first. So now we're again in the C is 1 position. So if this value is bigger than the current call max value, which is still -3, which it is, then it's going to save this value as that max value for column 1, because C is 1. So again, I think this works. If you need to work on the logic, then write down and do it kind of by hand will give you the idea. So I think we're going to do the exact same logic with our rows, except we're looking at the rows now, and we don't care about the R value, and we only have one column in row max, so we're only looking and replacing the values in the first column of our row max. So row max R comma 1 becomes whatever value we're looking at. I need to suppress some things. There we go. And then finally, this is just our mat max. And I should be consistent with my capitalization here. Mat max has to look at every single, actually mat max is just a scalar. So if it's bigger than whatever number it is, change that value to the current value. All right, so we need to end our for loops. And maybe I just want to display call max, display row max. And I'm using dis because it's just a little more efficient on my command window screen over here. I'm gonna have to remember which ones are which, but oops. I think I've got everything suppressed up top. Let's give it a run. All right, so we are gonna wanna see what A max is just to see. All right, so here is my first column. The largest number in my first column is a 16. It looks like we grabbed it. The largest number in my second column is a 7. Yepper. Third column, we've got a 20. There it is. Fourth column, 15. Nailed it. Last column, the largest is the -1. So it looks like our column max worked. Now we got to look row-wise. So in our first row, the largest number I see is 15. In the next row, the largest number I see is a 20. And in the third row, the largest number is 16. So it looks like our column and row maxes are both working. And then I think I forgot to say something here. Yeah, we built the size. We just wanted the scalar to change, not building a matrix. So let me rerun that. There we go. So now this time, the largest in the whole matrix is a 20. And there we go, there's a 20 for our mat max. So I did have a little error there because we just want the scalar, that single number, to become whatever value as we're comparing. All right, so I think that takes care of A. You guys should have started with this is homework 7, question 3A. All right, so we did A, maximum value of each column, row, and of the entire matrix. And now it asks us to check our answers by comparing with the built-in function of max. Okie dokie. So I think I'm just going to comment these out. I don't need to show those every single time. And here I can start part B. So this is homework 7, question 3B. All right, so if we maybe call this call max that's it. All right, so the column max 2 maybe equals max, and maybe we need to consult the documentation about max a little bit to figure out what's going on with it. So right click, help on it. So if we just say max A, it returns the maximum elements of an array. Okay, but if it's a matrix, that's what we are in, because our A mat is a matrix. If it's a matrix, then max A is a row vector containing all the maximum values of each column. Oh, so we can just literally say A mat here, and we are going to get the same value, right? Because this is a row vector, a 1 row by 5 columns, gives us the max of that thing. Now, call row max 2 is a little more difficult, unless we think of it as if we transpose our AMAT, then our rows became our columns. So we could just do mat, AMAT, max of AMAT transposed. But I want it to be a column vector, so I'm going to transpose again at the end. Right, so this takes our 3 by 5 AMAT and makes it a 5 by 3. So now my columns are the 3. I can find the max. Well, just the max function by itself returns the maxes of each column. And then we're going to transpose that again so that they become the maxes of each row. So I want to say that's right. And then mat max 2, we can just combo, because if it was a vector, it finds the maximum of the vector, right? So that makes it a scalar. So this first part returns callmax2. It's the same command as callmax2, which is a row vector of the maxes of the columns. So by doing this again, the max function on a vector is just a scalar, whatever the largest value is in the whole vector. So I think we're good to go. All right, and then maybe, so we could just run this and compare the values of callmax2 with callmax from above and see if they're the same. But I'm going to do a little more advanced checking here real quick. So I'm just going to say my call check is the difference between call max and call max 2. So if I subtract those two, and that difference, if they're exactly the same, I should have a 0, 0, 0, 0, 0. So my column check, I'm going to add all of those up. If I add up a whole bunch of zeros, I should just get a 0. And then I think I'm going to do the exact same thing for my row. So again, if my row max and my row max 2 are exactly the same, I should just get a vector of zeros. If I sum up that vector of zeros, I should get 0. And then my mat check, I don't think I need to sum anymore because these are two scalars. Mat max minus mat max 2. Right? And then I can say if call check does not equal 0, this error in column maxes. This just saves me some time on the back end by putting this in. And now that I've done this, I can copy and paste this for future things. But here I can say row and mat and row and mat. Right, so again, the logic is if these two, I don't know why I left that open, if the built-in function is returning the exact same value as the nested for loop values that I calculated above, then their differences should be 0. And if I add up a bunch of zeros, then my checker should have a value of 0. If it's not 0, I have an error in the columns. Same thing, if my rows aren't 0, I have an error in my rows. And if my mat isn't, I have an error in my mat. So if I run this, I'm not popping out any errors, even though my mat is changing. So I think it's working. If I wanted to make sure that my checker is working, what I could do is just make a brand new AMAT down here, right? So I'm assuming that the maximum on the second time around isn't going to be the same. So I'm going to run it, and it looks like it's working, right? Because I came up with the maximums from this first AMAT, and then I made a new AMAT and found the values, the maximums from it. Those two maxes probably aren't the same, and they sure weren't, so we got errors running everywhere. I run the whole thing, it looks like I'm getting the errors every time, but as soon as I say, nope, use the same matrix, look at the maxes from the same matrix, no errors. All right, so I think we're good. Were we asked to do anything else from part 3? Nope. So I think we are good to go on question 3. I will be making another video from homework 7, question 4.